All right. So, as we saw with deductive arguments, there's another level, a second level of evaluation to apply to inductive arguments. With deductive arguments, remember it was valid and invalid, and then sound or unsound. Here with inductive arguments, it's strong and weak, and then cogent or uncogent. So that's what we'll be talking about here. So, similarly to deductive arguments, if an argument is weak, it is automatically uncogent, right? So you don't have to think about it. You can just automatically keep writing, so to speak, uncogent. On the other hand, if an argument is strong, an inductive argument is strong, it is either cogent or uncogent. It can go either way, just like with valid arguments. They can be sound or unsound. So what makes an inductive argument cogent? Well, it would have to be strong, and then it would also have to turn out that all of the premises are actually true in that argument. For an uncogent argument, right, well, if it's weak, it's automatically uncogent, and if it's strong, it will be uncogent if even one of the premises turns out to be false, right? So you'll notice there it's really a parallel kind of evaluation with sound and unsound, right? So we need to put this into practice, though, and so we'll go ahead and go back to those previous arguments, right? So in other words, thinking about the die, right? I had an argument that said, I have a regular six-sided die, therefore when I throw it, it'll probably come up a number greater than 1. So that was a strong argument. And so then we're going to ask, okay, it's a strong argument. Is it now cogent or uncogent, right? And so what we'd be asking about there is, well, is it really a regular six-sided die? Is the premise true, right? If it is, then not only would it be strong, but it would also be cogent. On the other hand, if it turns out that rather than holding a regular six-sided die, I lied, and in fact it's a loaded dice, right? It's a loaded die, so that it always comes up on a 1, for example, or whatever it might be, then although the argument would be strong, because it would be likely if it really were a regular six-sided die, so it would be strong, but if it turns out that the premise is false, then it would be uncogent, right? Okay. Another argument I offered, though, I have a regular six-sided die, therefore when I throw it, it'll probably come up a 6. Now that is a weak inductive argument. If it's weak, it's automatically uncogent, right? So you'll notice here as well then that this whole business about cogency, whether or not an inductive argument is cogent or not, is important. Cogent inductive arguments are the, again, sort of the pay dirt of inductive logic, right? In other words, a cogent inductive argument is not one where the conclusion is guaranteed, but it is one where the conclusion is in fact likely in the real world. And that's, of course, what we'd be looking to gain out of an inductive argument. All right. In terms of the other previous arguments, we had the one about blackjack, right, just to refer to that really quickly. So if I said, okay, I've got a pair of 10s, therefore I'll probably win if I take one more card, well, that was weak, right? It's not likely that I would win if I took one more card. And so if it's weak, it's automatically uncogent. On the other hand, if I say, oh, I've got a pair of 10s, therefore I'll probably win if I just stay put, that is, I don't take any more cards, then we would say, well, that's a strong argument. We know that. Is it cogent or not? Well, we'd ask, am I telling the truth? Do I really have a pair of 10s? If I really did, not only would it be strong, but it would also be cogent. On the other hand, if it turns out I was just bluffing or I was lying, which really isn't part of blackjack, but at any rate, if it turned out instead of having a pair of 10s, I had a 3 and a 2, then though the argument would be strong, it would be uncogent because my premise would turn out to be false. I don't have a pair of 10s in reality. All right, we'll put this into practice again here, and we look at some exercises from the text. But before we do, let's just note a couple other things here to remember. First of all, remember that whether an inductive argument is strong or weak and cogent or uncogent has nothing to do with whether or not the conclusion actually turns out to be true or false, right? You could have a strong cogent argument, but because we're dealing with probabilities here in inductive logic, the conclusion could still turn out to be false, though, again, it would not be likely. All right, just to reemphasize, be sure you're keeping the terminology straight here. We've got a lot of terms being thrown at you, so be sure to see the chart at the end of 1.4 and even to incorporate that into your note sheet. I will tell you that when it comes to the second set of exercises on the exam, I will give you on that second set, I'll give you a whole bunch of arguments, right? And for each of those arguments, you're going to have to tell me several things about them. First of all, you will tell me if it's a deductive or inductive. Then you will tell me what type of deductive or inductive argument it is. So in other words, is it a prediction? Is it a categorical syllogism? All of that stuff that you looked at in 1.3. Now, if it's a deductive argument, you'll tell me as well if it's valid or invalid, and then also sound or unsound. And remember, to determine sound or unsound, you'll need to know the truth of the premises, and I will give you that information at the very end of the practice exam. I'll have a list of the facts that you'll need to know to be able to answer those things on the exam. When it comes to an inductive argument, though, you'll use different terminology. You'll tell me if it's strong or weak, and then cogent or uncogent. And again, you'll need to know the truth about the premises to determine cogency, and so I'll give you those facts at the end of the practice exam, which will be fairly straightforward. If you think you'll forget them, you can put them on your note sheet, and you could even ask me during the exam, the truth value of those claims anyway. Okay, and so finally here, I'll give you a quick example. So we have Baker, Rainier, and Adams are all volcanoes, so it seems clear that all the mountains in the Cascades are volcanoes. And this could definitely be one that I could offer on the exam. And then again, the first task would be, is it deductive or inductive? Obviously, we're talking about this in the context of inductive arguments, so you'd already suspect that. But can you go ahead and tell me what type of inductive argument it is? Now, as you're thinking about this one, usually people think it's either one of two kinds. It's either an argument from analogy, or they think it's an inductive generalization. Now, in this case, and those two arguments are often confused with one another. In this case, because the conclusion is about all the mountains in the Cascades, right? The conclusion is about all of them, we would call it an inductive generalization. In other words, when you start off with a small sample, in this case 3 mountains, Baker, Rainier, and Adams, and then conclude about all of that thing, whatever it is, we're dealing with an inductive generalization. Arguments from analogy will compare typically 2 things and say that because they're similar in certain ways, they will have other features in common. But that's really not what we're looking at here. So it's an inductive generalization, it's an inductive argument, obviously. So we need to tell if it's strong or weak. In other words, let's assume that Baker, Rainier, and Adams are all volcanoes. Would that make it likely then that all the mountains in the Cascades are volcanoes? Well, we can use a little bit of background knowledge here, right? And we know that there are many, many mountains in the Cascades. And so the mere fact that 3 of them happen to be volcanoes would not make it likely that all of them are volcanoes, right? In fact, for inductive generalizations, it can be very difficult to come up with a strong inductive generalization. They tend to be fairly weak, typically. Since it is weak, as we've already determined, then we would go ahead and say it is uncogent, right? And so you don't even have to, if you didn't know, you don't have to look up whether or not Baker, Rainier, and Adams are all volcanoes. It's weak, so it's automatically uncogent.